Any questions, y'all? $30. You got it. Let's take a look. $30 is interesting and also easy to mess up. So let's see. We've got a cylindrical box that we are wrapping. Oh my goodness. Let's try a little harder. So, some cylinder. Perfect. Gorgeous. We have 120 centimeters of ribbon to use. The other 10 centimeters will be used for the bow. 120 centimeters of ribbon. We want to maximize volume under these constraints. Well, first of all, the volume of a cylinder, give me 1 second. MK finally arrived, so I can mark her present. Let's see. Okay. So, the volume of the cylinder, we know, or you looked up, or you could have asked me, is volume equals pi r squared h. Well, before we maximize this, I'm going to need h in terms of r. And that's going to come from my constraint. So 120 centimeters of ribbon is being used to, let's see. So the ribbon is going to be wrapped like so. And then also on the bottom it will mirror the top, and on the back, so basically on the top there are 4 streaks of ribbon, on the side there are 4 streaks of ribbon, and on the bottom there are 4 streaks of ribbon, right? Is that good so far? So the length of the ribbon will come from 4 radius on the top, 4 radius on the bottom. So we say 8 radius worth plus 4h. So it's 8 radius is radii and 4 heights. That's 1, 2, 3, 4. Is this good so far, Jalen? Do you have any questions about this equation? So I need to solve for h, so that's 120 minus 8r divided by 4. That would be 30 minus 2r. I will substitute it back in. I get volume equals pi r squared times 30 minus 2r. I'm going to go ahead and distribute. It will be easier to differentiate. So I get 30 pi r squared minus 2 pi r cubed. So let's go ahead and differentiate. I get 60 pi r minus 6 pi r squared. So, and I want to set this equal to 0. Go ahead and start factoring it. I can divide by 6 pi r, and I'm left with 10 minus r. So r equals 0 or r equals 10. Well, so at this point you could do your number line and plug in all of these things and check which one's a maximum. But if you think about it for a moment, wouldn't r equals 0 be 0 volume? So it definitely can't be that. Usually if you just think on it for a moment, you don't even have to do any calculus to rule out one of these guys. So clearly this has to be the answer. And so if r is 10, and I want to know the volume's actually right over here. I can plug 10 into that. So I get pi times 10 squared times 30 minus 2 lots of 10, so that's 10. So this is 1000 pi. Is this okay? Do you have any questions regarding this, Jalen? Cool. Wonderful. Optimization is difficult for a long time until you start really understanding what's going on. So these are going to be hard problems, and if you guys had trouble with these, that's totally fine. That's why I only assigned 3 or 4 of them. 19 or 20? Which one do you want? Will we have a quiz over this? Yeah, there will be one question. It'll be easy though. The quiz question will be just like one of the homework questions. So if you understand all of the homework questions, easy peasy. $19. Box has 32 cubic inches of volume. Don't worry, Jalen, it will be fine. So we have a box, and actually the stipulation is that the bases are square, aren't they? So here's my side. So the bases are square. So the volume is 32 cubic units. The bases are square, so length, width, height. Actually, length and width are the same thing. I'm going to go ahead and call them x. So given that the volume is 32, I want to minimize surface area. Well, the surface area of the box is just going to be the area of the 6 faces. So let me do the top and the bottom. So this bottom face is just going to be x squared. Same story for the top face. So for the top and the bottom, I have 2x squared. The 4 sides are all the same. They're xh, 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 and xh. So we get plus 4xh. These are the 4 sides. Is this good so far, Avery? Okay, so we want to, well, we need this in one variable, so we're going to go back to our constraint. And so the volume is x squared h. So I want to solve for h in terms of x squared. You could do it the other way, but this is easier. It takes less work because there's only one h and it's not squared or anything like that. So I'm going to solve for h in terms of x squared, and h equals 32 divided by x squared. I'm going to substitute this in for that h. So I get surface area equals 2x squared plus 4x times 32 over x squared. I'm going to go ahead and simplify because these will cross out. If you see action like this, it's usually an indication that you're doing something right. And so I get 2x squared plus 128 over x. Whoops. I'm going to go ahead and call this plus 128x to the negative 1 power. So that's my surface area formula. And I can differentiate it for x minus 128x to the negative 2. And I want to set this equal to 0. I'm going to go ahead and move this to the left side. 128 over x squared equals 4x. I want to get all the x's in the same place, so I'll multiply this to both sides. 128 equals 4x cubed. Divide both sides by 4. X cubed equals 32. X equals the cube root of 32. So, if we want to find h, we're going to have to go back to the volume, knowing that it's 32 cubic units. So volume is x squared h. It is cube root of 32 squared times h. So if you divide this, you will get h is also the cube root of 32. And in optimization problems, it's usually pretty acceptable if you want to actually write decimals instead of cube root 32. I will accept decimals here. Does this answer your question, Avery? So curiously, or not so curiously, No, there's gonna be a quiz champ. Sorry, man. Um, the cube minimizes the surface area for rectangular prisms, just like the sphere minimizes surface area for ellipsoids. Right? Ellipsoids are little like bean-shaped like solids, kind of like a football almost. Anyway, any more questions? Tell you what, when I write the quiz, I'm going to think about this. So this isn't a promise, but maybe I will tell you to review 3 or 4 problems, and the quiz problem will be very similar to one of them. Does that make sense? So it's like I would basically give you a test bank. So again, that's not a promise, but I'll be thinking about it. Yeah, it sure does sound good, doesn't it? Frictionless, nice and smooth. Before I get into today, I just wanted to mention, so we know Newton invented calculus. Actually, he invented calculus while he was quarantined from the plague. So, what are you doing with your free time? So that's my question to y'all. You should be thinking of new branches of math. That's what you should be doing. Imagine being so bored you invent calculus. And furthermore, that to him it was just trivial to just do it. My man was a genius. It's crazy. Okay, so today we are talking about the antiderivative. To antiderive is the opposite of to derive. Whenever we do something in math, some kind of forward operation like addition or multiplication, it's helpful to know how to do it backwards. Subtraction, division, inverse functions, and in this case, anti-differentiation. So, we're going to talk about the antiderivative. First of all, I'm just going to, let me pull out my notes. So let me write this down. We say, if there exists some function, capital F of x, and you differentiate it, you're going to get a new function. And so we say this relationship between these two, we say f prime is the antiderivative. Let me put an example to this. I don't know, it doesn't really matter. Let me just say, let's consider f of x equals 10x. I'm going to differentiate it, and so the derivative is 10. So we say 10x is the antiderivative of 10. Does that make sense? I'll do another one. If f of x equals x squared, f prime of x is 2x. We say that x squared is the antiderivative of 2x. In other words, we are asking to find what function, when derived, gives you 2x. And it's x squared. So we want to figure out how to do this because it's actually pretty difficult. So we're going to start talking about that today. Jesus. One second. Helen's Wi-Fi is down. So sad. Give me 1 second to respond to her. Alrighty. So, let's see. I want to I want to start by just demonstrating a couple things. I'm going to differentiate some functions. Right, so let's see. X squared becomes 2x. X cubed becomes 3x. X to the fourth becomes, 3x squared. X to the fourth becomes 4x cubed, and so on, right? That's the power rule that we already know, right? This number comes down and the exponent decreases by 1. So if we want to antiderive, we want to go backwards. So, I mean, for instance, what is the antiderivative of 8x to the 7th? Well, that means there existed something that had the exponent that came down, so that exponent must have been an 8. Well, does that make sense? Because the 8 would have come down, you get 8x to the 7th. So this is kind of the idea here. And we're going to talk about formally how we're going to make sure this always works. So do you kind of get the idea here? So this is the function that when you derive it gives you 8x to the 7th. I want you to notice something. So let's see. I'm going to write two functions. Capital functions are used to denote antiderivatives. I'm going to differentiate this. So f prime is 2x and g prime is 2x. Aren't those the same thing, right? So x squared plus 3 is an antiderivative of 2x, and also x squared minus 1 is an antiderivative of 2x. There is no unique antiderivative, and the reason for this is because the constant can literally be anything, right? Go back to what a derivative is. A derivative really means slope. And this constant on the outside is the vertical shift of a function up and down. Does the vertical shift of a function up and down affect the slope at all? No. And by the way, I'll just graph these two functions, x squared plus 3 and x squared minus 1. See how they have the same slope everywhere? The vertical shift does not matter. Okay, so we say and there's a sign for antiderivative too. So let's say f of x is the antiderivative and f of x is given by this stuff, right? This is an indefinite integral. Give me 1 second, y'all. So, the indefinite integral of a function, and this dx means with respect to x, that just means that x is the variable we're talking about. The indefinite integral of a function of x with respect to x is its antiderivative. So, let me give another example. So, I want to find the antiderivative of 2x. And sorry, so I want to find the antiderivative of 2x. So what function when derived gives 2x? Well, that means the 2 must have come down to the side, so it had to be x squared. Does that work? The 2 comes down to the side and the exponent decreases to 1. So yes, that works. And not only is it x squared, that's not really true. It could be x squared or any vertical shift thereof. So we always have this plus c. This gives us the entire family of antiderivatives of 2x. So let's actually formalize this backwards power rule type thing that's going on. And so, let me start a new page here. So again, let's just review the power rule, and we're going to try to do it backwards, right? So if you have x to the 9th, differentiating it, it becomes 9x to the 8th. The number comes down and decreases by 1. So you multiply the old number and decrease by 1. So if I want to find, so let's see, if f of x equals x to the n, f prime of x is equal to n times x to the n minus 1. Now, if f of x equals x to the n, its antiderivative, big F of x, is going to be x to the n plus 1 divided by n plus 1. So take a look at this. If you were to differentiate it, the n plus 1 comes down and cancels out with this n plus 1 and decreases by 1, so you're left with x to the n. So let's use this rule. This is the backwards power rule here. Let's try x to the 7th. So for function x to the 7th, its antiderivative, big X, is x to the 7 plus 1, so x to the 8th over 8. Is that true? I can check this by differentiating. Well, if I differentiate that, I bring the 8 down, so I get 8x to the 7th, divide by 8, and the 8's cancel out. So it is x to the 7th, and I even forgot my plus c. Never forget the plus c. Let's try another one. I'm going to try f of x equals x to the 3rd. So I want big F of x, the antiderivative, or, right, this is symbolized as the indefinite integral of x cubed with respect to x. And so I increase the exponent by 1 and divide by that new exponent. And I add c. I'm going to give you guys a couple to try. Let's see. We'll do pink here. Please find these antiderivatives. By the way, this is like a really tall, skinny S. I'm probably going to draw it different every time. That's just because my penmanship is terrible. But this is probably one of the better looking ones, one of these two, right? And again, this is our rule over here in the yellow box. Anybody still working? Have you guys finished? Can you let me know if you've finished, please? Cool. So the rule, again, is to increase the exponent by 1 and then divide by that new exponent. So here we get x to the 6th over 6, x to the 7th over 7, and x to the 12th over 12. Not too bad, right? Let's try... Whoops, did I paste that twice? Yes, you would add plus c. Thank you. Yes, this is the bane of all calculus students and teachers. These all need plus c's. Isn't that annoying, right? So basically this constant could be anything. It could be 7, it could be pi, it could be square root of 3. Getting a trillion emails right now. Okay, so let's try something else. Consider if I had what do I want to do? Let's find the antiderivative of 1 over x squared. What's the exponent here? Isn't it actually x to the negative 2? So let's go ahead and write that. So I increase the exponent by 1, and by increase I mean in the positive direction. So if I'm going in the positive direction 1 unit from negative 2, that means negative 1. And I divide by that new exponent. So to divide by negative 1 just makes a negative. So here is my antiderivative. Let me try another one. Let's find the antiderivative of square root x. Well, what's the actual exponent there? It's x to the 1/2. And so I want to increase the exponent by 1, so I get x to the 3/2, and then divide by the new exponent. And so if I divide by 3/2, and this is plus c by the way, if I divide by 3/2, that's the same thing as multiplying by 2/3. Here's our second answer here. So, let's see. Let's have you guys try a couple. I would like you to try one over x to the 5th and x to the 3/7. So I assume y'all are still working. Are you guys still working? No, thank you. Especially since this is my first time teaching calculus, I have no clue how long it takes students to do things, right? And this is your first time doing it as well. So I'm not saying you're to blame, right? So this is new. Of course, it's going to be difficult. Okay, so I have this is x to the negative fifth here. Increase the exponent by 1 and divide by the new exponent. So there's our answer. Increase the exponent by 1, so that would be x to the 11/7 and divide by the new exponent plus c. Any questions about these two? So now we know how to deal with integer exponents and rational exponents. And that already covers a whole lot of math, thankfully. Okay, so I want to say, MK, do you have a, wouldn't this be 10/7? 3 plus 7 is 11, isn't it? Okay, thank you. One second. So, what if we have not just x squared, but what if we had like integral of 3x squared? How do we deal with that? So we can actually, there's a rule for this. So for constant multiples, the integral of a constant times f of x, the antiderivative is equal to said constant times the derivative of f of x. In other words, going back to our example, we can forget about the 3 until we're finished, if that makes sense. So, and go back to that example, we will rewrite this as 3 antiderivatives of x squared. And the antiderivative of x squared is raise the exponent by 1 and divide by the new exponent. Well, 3/3 cancels out, so I just get x cubed plus c. Let me try another one. What about 16x cubed? So we'll rewrite it as 16 antiderivatives of x cubed. And the antiderivative of x cubed is raise the exponent to 4 and divide by 4. That's 16/4. That's the 16 from earlier. 16/4, I get 4x to the 4th plus c. So the constant is no issue. I just save it until the end when I'm done. Now what instead if I have an addition or subtraction, a sum or a difference of functions? Consider the integral of x squared plus x cubed. How do I deal with this? Thankfully, it really is as simple as the integral of x squared plus the integral of x cubed. It really is that simple. So we say the integral of f of x plus or minus g of x is equal to the integral of f of x plus or minus, whichever one we were talking about earlier, it's the same one, plus or minus integral of g of x. This is the sum or difference rule. So we have a constant rule and a sum or difference rule. Pardon my dog, goodness. So let's try one of these. So in fact, let's try this one from earlier. Integral of x squared plus integral of x cubed. I'm going to bring this down. The integral of x squared is x cubed over 3. Raise the 2 to a 3 and divide by the new one. Raise the 3 to a 4 and divide by the new one. So there we go. Really is that simple, thankfully. And these things can happen in conjunction, both the constant multiple and the sum or difference. So especially, let's consider what if you have the integral of 6x squared plus 8x minus 9? The antiderivative. What's the antiderivative here? Do you have a question, MK? Yeah. And so this is a sum of two functions and a difference of the third, and this is 6 of them and 8 of them and negative 9 of them. So we will rewrite this as 6 integrals of x squared plus 8 integrals or antiderivatives of x minus 9 integrals of of 1. Right? That's either 1 or this can even just be not there. It's just like integral dx. But if it's written that way, it implies that it's a 1 there. Does that make sense? So I'll leave it blank there, and then we'll say that this is minus 9 integrals of 1 dx. Okay, so 6 integrals of x squared. The antiderivative of x squared is x cubed over 3. Increase the exponent by 1 and divide by that new exponent, plus 8 integrals of x to the 1. So increase the 1 to a 2 and divide by that 2, minus 9 integrals of 1. So that is x to the 0, isn't it? So increase the 0 to a 1 and divide by 1, so it just becomes minus 9x. So we are left with 6/3, that's 2x cubed, plus 8 halves, that's 4x squared, minus 9x plus c. What would you like to see, MK? Is it this? This is in the book, by the way. I'm going to assume you have what you need. So, let's see. Why is it not? Huh. That's kind of sad. I'll just rewrite it. So, the constant rule is the integral of k times f of x dx is k integrals of f of x dx. So I would like you to use this rule, please, to do antiderivative of 2v cubed dv. Notice the x's have just changed to v's. There's nothing wrong with that. And also the antiderivative of 12 divided by w to the 5th dw. Try these two. Are you guys still working? We're done. All right. So this is 2 antiderivatives of v cubed. That would be v to the 4th over 4 times 2. Or 2v to the 4th plus c. This would be 12 antiderivatives of w to the negative 5. So increase the negative 5 by 1, you get negative 4. Divide by negative 4. 12 divided by negative 4 is negative 3 w to the negative 4. Any questions about these? Oops. I'll give you one last one to try. Three x squared minus 4x plus 5. So notice you'll have to split this into 3 integrals. So go ahead and attempt that. Is anybody finished? Okay, let's take a look. I'm gonna do this. Geez, I've really run out of room. I'll erase this stuff. So we get 3 integrals of x squared, 3 antiderivatives. So first I'll show you how you would formally expand this. Eventually you'll be able to skip this step. You don't have to, but I think you know what I mean, right? So once you guys do a trillion of these, this step will come naturally. So 3 integrals of x squared. The antiderivative of x squared is x cubed over 3. Increase the 2 to a 3, divide by the 3. And there's this 3 from earlier. Minus 4 integrals of x. The antiderivative of x to the 1 is increase it to a 2, divide by 2. And then plus 5 antiderivatives of 1, right? And the antiderivative of 1 is just x. So here I get 3/3 x cubed, which is just x cubed, minus 4/2 minus 2x squared plus 5x plus c. Any questions about antiderivatives or integrals or anything like that? Alright, good work today. The homework is in the book, and I'll post it on the portal soon, but here it is, and I'll also send you a picture of the book. Page 366, 4, 5, 6, 8, 9, 12, 13, 14, 19, and 22. It looks long because they're all listed out, but really it's just 11 problems, so not too long. Alright, have a great day, y'all.